Let's see this question. In this, if P is the momentum of the fastest electron ejected from a metal surface after the irradiation of light. So in this, let us suppose there is a photographic plate. On this, a light has been ejected with a photon of some certain wavelength lambda. It is the electron will be coming out with certain kinetic energy. This is photoelectric equation. Energy of a photon is equals to work function plus kinetic energy. This is the photoelectric equation. Now he says that in this, he says that assume the kinetic energy of the ejected photoelectron to be very, very high in comparison to work function. This means that E is equals to this work function is very, very small number. So we can neglect it. We can directly write E is equals to kinetic energy because addition of this to kinetic energy doesn't make much difference because let us assume if kinetic energy is some 10,000 joules and work function is some 1 joule. Okay. So kinetic energy plus work function is becoming 10,001 joule, which doesn't matter. It doesn't have any kind of significance. So we can just remove it and we can simply write energy of a photon is equals to kinetic energy of the electron. So energy of the photon can be written as hc by lambda is equals to kinetic energy of the electron. As we also know, kinetic energy is equals to P square by 2m. Okay, kinetic energy is equals to momentum square upon 2m. How did we get this? Kinetic energy is equals to half mv square multiply kinetic energy is equals to half mv square multiply and divide it with m. You are going to get m square v square by 2m is equals to kinetic energy. This m square u square is nothing but momentum square is equals to 2m into kinetic energy, or kinetic energy is equals to p square by 2. Okay. So from this, now we can write kinetic energy as p square by 12. Okay. P square by 12. P square by 12. Okay. Now what he says, if P is the momentum of the fastest electron, okay, fine. And for 1.5 momentum, I can write 1 by lambda is directly proportional to P square, or P square is inversely proportional to lambda. We can write it as lambda 2 by lambda 1 is equals to P1 square upon P2 square. So, first one, it is lambda 2 is equals to lambda 2 by lambda is equals to P1, the fastest the metal surface of, yeah. So this is simple P square. This is 1.5 P whole square. Okay. So what you are going to get? Lambda 2 by lambda is equals to P square upon 1.5 whole square into P square. This and this gets cancelled. Lambda is equals to 1.5 whole square into lambda 2. This will be 1.5 whole square can be written as 15 by 10 whole square. 5 3's, 5 2's. So that would be lambda is equals to 9 by 4 lambda 2, or lambda 2 is equals to 4 by 9 lambda. Okay, the answer is lambda 2 is equals to 4 by 9 lambda. That is option B would be my answer. Option B would be the answer. I hope you understood.